Okay, so let's get back. So we were talking about this visual hierarchy, and as I mentioned in the last part of the video, the size of the receptive field also increase as you go up into the hierarchy, which is very strange if you think about it very carefully, but I'll go rather quickly right now. So if you recall the neurons from V1, then you tend to find some neurons that that changes its response only within the very small tiny field around where you are fixating here, and that's this hierarchy level. And then one step above in the visual field V2, then it becomes slightly bigger, and then that's here, right? And then V4 has an even bigger receptive field, and that's here. And then IT, that's here, inferotemporal cortex. So, just roughly, very quickly, what I mean by the complicated kind of thing is that the reason why there is a visual hierarchy is not only to collect the input from many neurons across the visual field to, let's say, generate a more vivid color sensation, but it also is some kind of processing going on. So, for example, at the level of the IT, you start to find neurons that respond only to the face, but not other things. And for that, you need to probably some kind of have a combination of the features that makes up the face and then not others. And then that brings this IT's face selective neurons. But at the same time, because the neurons receptive field becomes really big, it can contain something that is not face related. So how to filter out this irrelevant thing is not now one of the important function of attention, which we will discuss in a couple of weeks. But for now, the important thing is to just understand that the receptive field size increases as you go up in the hierarchy. Okay, so in some of this section, cortex is vertically layered in a columnar fashion, and each layer has a distinct anatomical connectivity pattern with the rest of the brain areas. And this can be used to define visual hierarchy. And then which area in the brain supports our phenomenology, especially the color, is the question that we will go into next. But so far, is there any question? I forgot to take it after the break. No question so far? Fine? Okay, then let's move on. So where are after images coming from? That's the next topic. So here's the lilac chaser again. And then just to remind you, if you fixate here, then you see that the green dots moving around, and then you don't see even pink things anymore, which is very weird. And so this one of the explanation of this lilac chaser involves this concept called after image. So I'll just explain what it is. So this involves the demonstration. So please try to fixate at the center, somewhere around here, okay? And then don't move your eyes. Okay, so just look at this for a while, and then this. Don't move your eyes, okay? And then now what do you see? Can you describe your experience in the chat? Blue and pink. At the top of 2 boxes. Yes, okay, that's great. So is there any, does everybody agree with this? Okay. But if I don't alternate, okay, so let's just do one more thing. If I don't alternate, and then just fixate at the center, and then just go from here to there, then what happened? I hope that you guys also start to see, yeah, brown and dark shade of pink at the bottom and bottom two as well now. Yes, exactly. So, and I hope that everybody agrees with that. Thanks, Thurman. So this means that here, when you're seeing this, while your eyes are fixated at here, then neurons or retinal ganglion cells or cones, whatever, at the level of the eye, responding to this, redness starts to become fatigued. And then same goes for the green and the yellow and then blue. And then eventually this becomes red and then this becomes blue, this becomes yellow, this becomes green kind of person. But as Suleiman actually, pointed out, this is not exactly true. So I think what he described was this was a pink, and then this one is a bluish, and then the bottom one is a brown and dark shade of the pink at the bottom too as well. So here is a probably brown, and then this one is pink. I guess it may require some level of the observation and then recording of exactly what you see. And but the key point here is that the color experience is generated and it's in a complementary manner. But if you really pay attention to this phenomena as described by Salman, it's not exactly the kind of textbook effect. Partly because we are using this display, which contains many different kind of wavelengths, and that complicates the effect. Some of the textbook uses a very pure wavelengths, and that's not what we can observe readily on the display. But anyway, so if you look at the Wikipedia, here's what they say: after images occur because photochemical activity in the retina continues even when the eyes are no longer experiencing the original stimulus. And that's a sort of a standard explanation of the after image. Basically, after images are generated at the level of the eye, okay? And if this is the truth, then what it means is that the eye that receives the input that sends an output into both thalamus here and then to visual cortex. And then until you get to the visual cortex, input from left eye and the right eye does not become merged, okay? This is something that is a very important fact in the anatomy. So left side of the eye, and the right eye, and the left side of the left eye is segregated at the level of the thalamus, and also at the level of input of the visual cortex. And that result to this, next sort of the traditional view of the visual hierarchy or input. Up until LGN or thalamus, input from contralateral or ipsilateral eye, the same side of the eye or opposite side of the eye, is segregated. And then within layer 4, it reaches a separate population of the neurons here. And then that input is sent to neurons in layer 2, 3, and so on. And then finally it gets merged. And that's why explanation goes that you don't have two visions at the same time. Although left eye and the right eye are slightly different, you don't usually see this amalgamation of the two. but it's only single vision. And our conscious experience is supposedly corresponding to here. And that's why you don't see two doubled vision, okay? Now, then the question is here. So if it's true that after image is generated at the level of the cortex, right? Then what should happen phenomenologically? What should happen in your consciousness if we suppress stimulus from consciousness at the level of the cortex? Let me go one by one. This may be a bit complicated, so you should ask question if it's not clear, okay? So this is the visual illusion that I discovered when I was a grad student, called the continuous flash suppression. And some of the tutorial paper presentation use this, illusion. Here we show input to one eye. Let's say you close your right eye, and then you look at the center of the display here. Okay, and then on your through your left eye, you see red-green thing stripe on the left side and the right side at the same time. And one is horizontal, and one is tilted to the left. And then you see it for roughly like 5 seconds or something like that. And then, according to this after image explanation, your left eye corresponding area of the retinal ganglion cells should become fatigued, right? So it should predict something like here this is a green part and this is a red part, and then here this is a green part and then this is a red part. Like complementary pattern should be possible to see. Make sense so far? And then if you show, so this is one eye, and then other eye, this black and white pattern that changes every 100 milliseconds. So each pattern is actually different at 100 milliseconds. So that's the reason why it's called a continuous flash suppression. But you show different pattern each time. Then what happens is that during this perception of 5 seconds, you see the left side is sort of the this grating, horizontal grating is passing through to the left eye, because you don't have anything to compete in the other eye. But the right side is completely suppressed from the consciousness because of this black-white thing. So you even don't notice that there's something color presented on the right side of the vision. And then after 5 seconds, what happens? That's a question. Did you get the situation so far? Let me yes.
They presented both so they presented both this and this to one eye at the same time. And they also presented this to one eye.
Yes.
And because of the overlap between these two businesses,
yes.
And you only see it.
Exactly.
Okay.
So in other words, maybe I'll just then give you one more sketch here. So if this is a nose, and then this is your eye, right? And then using a mirror, then you can show something, some kind of display like this. And then this looks like this to the left eye, and then to the right eye, you show something like this kind of thing. And then this right side is flashing at 100 milliseconds. Does it make sense now?
Yeah.
Okay. All right, then the question is, So then this, let's do the poll here. I hope this so far is clear. I relaunched the poll. And, okay. So the question or option of the poll is that what happens after 5 seconds for this situation? A is that because retina is to the extent, fatigued here and then here. When this guy is removed, then you should see the after image as strong on the left side and right side. So it's basically the same after image on the both sides. That's option 1. And the option B is that maybe this is true, but I feel like there is something like for the consciousness or maybe cortex to play a role. So the right side might become maybe fainter, or you actually don't see the after image. So the right side weaker. That's the option B. And the option C is unsure. What's your opinion or expectation? Do you see the poll option?
Yeah.
Okay. Yep. Okay, so it's half-half. So that's good. Your prediction completely diverged. So the result is actually the following. So this is what we found in a real experiment, in fact. The after image on the right side became fainter compared to the left side. That's about like half the intensity compared to the left side, which is very surprising if the after image is, purely generated by the, retina, right? Because both the left eye and the right eye, or the left side and the right side of the retina was stimulated with the same level of the strength of the stimuli, and they are fatigued locally, and generated so it should be generating the same level of the after image, but afterwards you see this very strong after image on the left side, but weaker one from nowhere, in a sense. Because typical percept-wise, what you see is only this flickering thing. So that was my, in fact, first career publication in 2005, and that was published in Nature Neuroscience. That was partly because this method was new, and also partly because this after image reduction was very counterintuitive, or it implied something. So after the break, I'll discuss it, but I just want to, yep.
I had a question.
Yes.
So would it just be fainter because the other eye was fatigued less because you were showing it less instead of you cutting to the white black thing?
Sorry, can you say that again?
So you're splicing this one with this, right? Like the other eye, you're quickly changing the inputs.
This stimulus was presented for 5 seconds.
Right.
all the way to left eye here. And then this side is also 5 seconds all the way. Then there was no change.
Right. So this is left and C, right?
Left side and right side of the left eye.
Ah, okay. All right. Yeah.
Yeah. So just to remind you, left eye viewed something like this through the mirror, and so what they were looking at is something like maybe I should have prepared this type of the visual then.
So, but in the other eye, this is just black white stuff continuously. It's not like being swapped with this stuff.
Wait a sec.
Yeah.
Okay. So what were you saying?
So in the other eye, this is all that you're showing. You're not like changing this with this and then swapping them.
No. We the right eye receives only this one or this.
Yeah. Okay.
There was no swap here.
Right.
Within right eye's right side, this side itself was swapped.
Right. Yeah.
So imagine that if you are in this experiment and you close your right eye, then what you see is exactly this.
Right.
Which means that left eye is fatigued with this stimulus to the same level as the left side and the right side of the left eye.
Yeah. Yeah. Makes sense.
Make sense? And then if you close your left eye, then all you see is this flickering thing, and there has been no after image generated here and here.
Right.
Right? But then somewhere in the brain, these two are combined, and then you see this phenomenal vision. And that's this.
Yeah. Okay.
Then afterwards, you see this after image.
Yeah. Got it.
Okay? Then if retina is everything that generates an after image, then now that this is already gone, nothing is there. And so after image comes from remnant activity from here, right? On both sides. And then that should result in the both strong after image.
Yeah, I understand.
But it didn't.
Right.
Why? That's the question.
Yeah.
So if I'll come back with the answer after 5-minute break. But if you can type in your hypothesis in the chat, that would be great.